Okay, well, if this is 0, it's very clear that we get this solution, but then we have a plus or minus nothing.
Right.
So we'll have one solution, but this is a second order equation, it has to have 2. Again, we haven't proved that, and we're not going to prove it, but we're going to see why, okay, in terms of direction fields and so forth. We haven't yet done that because most applications in engineering don't require you to understand why. Okay. However, this is a math course, so we're going to talk about why, and that can be beneficial. Okay, so x2 is what? Well, how do we deal with the case of repeated solutions?
It's a multiple of x1.
It's going to be, yeah, x2 is going to be some multiple of x1, and we have this process called reduction of order. Okay? We don't have to go through that process to come up with our second solution when we have constant coefficients. If we don't have constant coefficients, typically we need to use reduction of order, and hopefully we're able to then find a second solution, if we have one. Okay? But right now, without going into reduction of order, we slap a T on the solution.
Okay, so it's
Okay.
just like last night then.
And now we have a solution set. And you can verify that this is a solution, and you can verify that these solutions are linearly independent. We did that. So that process is one that you would apply here to be sure that you're okay. And I'm not checking it, you know, so maybe I'm all wet. Okay? I haven't done the reduction of order. I'm not totally convinced that's going to be right. I would want to check it. Okay? But as it turns out, when you have constant coefficients, that's going to work. Okay? And we did an example in class, I believe last time or the time before, that verified that for one specific case. And it's the same in every case. Okay, so now we have our 2 solutions. Okay, what do the graphs of these solutions look like? So, first of all, our x1, well, it's going to be decreasing exponential. So here's our x1 solution. What's our x2 solution going to look like?